What if I told you that the image of the room you're sitting in right now, the screen in front of you, the light coming through the window, the colors on your desk, that none of it actually exists anywhere in your brain?
Right, because, I mean, logically, we know there is no light inside your skull. It is pitch black in there.
Exactly. It's totally dark. Yet you feel with absolute certainty that you are looking out at the world through your eyes, like a little pilot sitting in a cockpit. But the truth, according to some of the most rigorous cognitive science we have, is that everything you are experiencing right now is just this highly controlled hallucination.
Which is a deeply, deeply unsettling thought. We are wired to trust our senses completely.
Well, for sure.
To be told that our conscious experience is essentially an interface, like a simplified sketch generated by a dark, silent biological machine, it really feels like a betrayal of our own reality.
It does. And that feeling of betrayal, that deep skepticism you might be feeling right now, that is exactly why we're dedicating this deep dive to one of the most provocative frameworks in modern philosophy and cognitive science.
We're pulling heavily today from Daniel Dennett's monumental work, from bacteria to Bach and Back.
Yeah, and we are speaking directly to you, the listener. Maybe you're an undergraduate student sitting in a library right now, procrastinating on a psychology paper. Or maybe you're just someone trying to figure out how your own mind works.
Right, because you might be perfectly comfortable with science explaining how your liver filters toxins or, how the heart pumps blood. Those are biological machines.
Sure.
But when someone points that exact same scientific lens at your inner thoughts, your feelings of love, your sense of self, it feels like science is trespassing.
Trespassing is the perfect word. It feels like a violation of something sacred.
Hmm?
The defense mechanisms just immediately go up. And honestly, it's a completely rational defense mechanism.
Absolutely.
Because when you look at the sheer subjective beauty of human experience, like listening to a piece of music, or that sudden flash of insight when a complex math equation finally clicks, it feels impossible, almost insulting, to suggest it all boils down to just chemistry and physics.
So our mission for this deep dive is to tackle that resistance head on. We're going to map out the journey from the very first chemical reactions on Earth all the way to the poetry-writing, self-aware human mind.
And Dennett calls the steps on this journey his strange inversions of reasoning.
Right. These are concepts that require you to take everything you intuitively believe about how intelligence works and just flip it completely upside down.
Okay, so let's outline this. We can trace this evolution by looking at three major conceptual shifts.
Yeah, the first one requires us to break our assumption that complex designs always come from a smarter designer.
That's the turning our world upside down part.
Exactly. Then the second shift looks at how, against all odds, human culture actually allowed genuine, forward-thinking, intelligent design to emerge from that blind evolutionary process.
From evolution to intelligent design.
Right. And the third, which is usually the hardest to swallow, is turning our minds inside out, understanding consciousness as an evolved user illusion.
I do want to offer a quick warning here. If you are used to feeling like the absolute captain of your own ship, like if you feel deeply that your conscious mind is this unified immaterial force that authors your destiny, this deep dive might feel a little jarring.
We are essentially going to dismantle the ship while you are still sailing it.
Yeah, good luck with that, right?
Right.
But if you can keep an open mind and bracket those gut intuitions for a while, there's this profound aha moment waiting on the other side.
To get to that aha moment, we really have to start at the absolute bottom. We have to strip away the magic and look at how biological systems can build staggering brilliance out of essentially nothing.
Okay, let's unpack this. Because before Charles Darwin came along, almost everyone, from the smartest philosophers to the average person on the street, operated under what Dennett calls the trickle-down theory of creation.
Right. It's the intuitive assumption that it takes a big, smart thing to make a lesser thing.
Think about human history. A blacksmith makes a horseshoe. A clockmaker makes a clock.
The creator always has more complexity, more foresight, and more intelligence than the object being created.
So when people looked at the universe, when they looked at the intricate gears of a human eye, or the aerodynamic perfection of a falcon's wing, the natural logical conclusion was that an ultimate intelligence had to be sitting at the top.
The greater creates the lesser. Design trickles down.
Which makes total sense because that is our daily lived experience. I mean, I can't build a smartphone by throwing rare earth metals into a blender and hoping for the best.
No, you definitely cannot.
I know it requires teams of engineers, blueprints, and deliberate top-down intelligent design.
But Darwin's theory of natural selection shattered that entire paradigm. He introduced what we call a bubble-up theory.
Bubble up, right?
Darwin proposed that you do not need a brilliant mind at the top to create a complex eye or a bird's wing. You can start with absolute ignorance.
Just mindless stuff.
Exactly, uncomprehending chemical components. And through the blind grinding process of differential reproduction and genetic mutation over millions of years, brilliant designs can bubble up from the bottom.
And Dennett calls this Darwin's strange inversion of reasoning. It's the idea that a process with no designer, no blueprint, and no end goal in mind can create biological machines that put our greatest human engineers to shame.
And the resistance to Darwin wasn't just religious, it was highly logical. People simply couldn't fathom how blind chance could engineer competence.
It just feels wrong.
But the fascinating parallel here is that almost a century later, Alan Turing discovered the exact same strange inversion, but in the realm of mathematics and computing.
Oh, right. Turing's strange inversion. Because in the 1930s, the word computer wasn't a machine, it was an actual job title.
Yeah, usually a person with a mathematics degree sitting in a room doing complex calculations for ballistics or astronomy.
So the assumption was that to do complex math, you had to understand math. You needed comprehension.
But Turing proved that assumption completely wrong. He conceptualized a machine, what we now call a Turing machine, that consisted of nothing but a long tape of symbols and a little read-write head.
Just blindly following rules.
Dead simple conditional rules. If it sees a 0, it flips it to a 1 and moves left. If it sees a 1, it leaves it alone and moves right.
The machine doesn't know what a number is.
It doesn't know what addition or calculus is at all. It exists in a state of absolute ignorance. Yet Turing proved mathematically that this mindless, uncomprehending machine could compute absolutely any mathematical problem that is computable.
So you don't need an intelligent designer to get brilliant biological design, and you don't need comprehension to get perfect computation.
Exactly. And this concept is the beating heart of Dennett's philosophy: competence without comprehension.
Competence without comprehension. That is such a key phrase for you to remember as you listen to this.
It's the single most important phrase to grasp if you want to understand the origins of the mind. It means that a system can be brilliantly adept at solving problems, surviving, and navigating its environment without having the slightest idea of what it's doing or why.
Let's ground this in biological reality for the student listening. Because if I think about a single-celled organism, like a bacterium in a petri dish, it swims toward a food source. It repairs its own DNA when damaged.
It has a highly complex metabolism.
Right. It's unbelievably competent at staying alive.
Yeah.
But does this mean early life was just blindly stumbling? Is there a tiny microscopic mind in there pondering the nutritional value of glucose?
Not at all. Its competence is the result of billions of years of trial and error. The variations that didn't swim toward the food simply died out.
They just perished.
Yeah. The ones that survived are running a hardwired blind algorithm. They are incredibly competent, but they comprehend nothing.
Okay, but how does that blind stumbling scale up? Because when you look at the major transitions in the history of life, it's hard not to see them as strokes of genius. Take the eukaryotic revolution.
Oh, that's a great example.
Right. About 2 billion years ago, you had these simple, single-celled organisms, bacteria and archaea. And then one day, an archaeon swallows a bacterium. But instead of digesting it, they merge.
And the bacterium eventually becomes the mitochondria, the powerhouse of the cell.
Which feels like an incredibly smart strategic partnership. I always compare it to a blind corporate merger. Like imagine Google buying a tiny, highly specialized startup. But in this scenario, Google has no CEO, no board of directors, no business plan, and no lawyers.
That would be chaotic.
Utterly chaotic. They just blindly stumble into the startup's office, absorb all the employees by accident, and by sheer dumb luck, the new combined entity ends up dominating the market because they happen to work well together.
That analogy is perfect because the lack of foresight is the key element there. There was no evolutionary blueprint that said, hey, if we combine these two cells, we will eventually get plants, animals, and humans.
It was just a blind collision.
Exactly. And the vast majority of those collisions resulted in death. But natural selection is the ultimate amplifier of incredibly rare, lucky events. When that specific merger happened, the resulting eukaryotic cell had so much more available energy, thanks to the new mitochondria, that it outcompeted everything else.
It was basically the first great technology transfer.
Yes, a technology transfer driven purely by luck and survival, not foresight.
And the sheer scale of what this bottom-up, blind persistence has achieved is staggering. Especially when you look at the recent timeline, once human beings entered the picture with our cultural tools.
You're thinking of the McCready explosion.
Yes. Paul McCready, the aerospace engineer, calculated this to illustrate the massive shift human technology caused in biology.
The statistics are honestly sobering. McCready looked at the terrestrial vertebrate biomass of the entire planet. 10,000 years ago, at the very dawn of human agriculture, human beings and our domesticated livestock accounted for roughly 0.1% of the terrestrial vertebrate biogas.
We were literally an evolutionary footnote, a rounding error on the global ecosystem.
But today, if you weigh all the terrestrial vertebrates on Earth, humans, our pets, and our livestock account for roughly 98% of the biomass.
98%.
Wild animals, every elephant, every tiger, every deer, every wild bird, they make up just 2%.
That is a terrifyingly fast biological takeover.
It is arguably the most dramatic shift in the history of the biosphere, and it happened in an evolutionary microsecond. And it highlights a fascinating tension regarding how we perceive our mental autonomy.
What do you mean?
Well, when you hear that humans control 98% of the biomass, it is incredibly tempting to revert back to the trickle-down theory. It makes us feel like we are the ultimate top-down intelligent designers. We think we conquered the planet because we possess this godlike mental control over our actions.
Oh, I see. Because I ask myself, do I feel like a collection of blind, uncomprehending parts? No, I don't. I feel like a unified entity. I feel like an immaterial I residing just behind my eyes, operating my body like a meat suit.
Right.
If I am just the result of blind, bottom-up Darwinian evolution, why does my conscious experience feel so incredibly coherent and deliberate?
To untangle that contradiction, we actually need to leave modern biology for a moment and step back into 17th century philosophy. We have to examine the legacy of René Descartes.
Ah, Descartes. I think, therefore I am. He's really the bedrock of how we intuitively view ourselves.
He was a brilliant polymath, deeply interested in anatomy and the new physics of his time. But when he sat in his room and introspected, when he turned his attention inward to examine his own thoughts, he hit a wall.
He couldn't reconcile it.
No. He looked at the mechanical clockwork of the physical world, and then he looked at his own ability to do calculus, to write poetry, to contemplate God. He simply could not conceive of any physical mechanism that could produce that kind of internal richness.
He just couldn't imagine a meat machine writing a symphony.
So he made a philosophical split. He concluded that the universe must be made of two completely different substances. There is the res extensa, the physical stuff that takes up space and obeys the laws of physics.
Okay.
And then there's the res cogitans, the thinking thing, the mind. He argued that the mind is fundamentally immaterial, a soul that somehow interfaces with the physical brain to steer the body. This is Cartesian dualism.
And Dennett calls this the Cartesian wound. It severed the mind from the physical world right at the dawn of modern science. And modern materialist science has been trying to stitch that wound closed ever since.
Yes, it has.
Take Francis Crick, the co-discoverer of DNA. He published a book in the 1990s called The Astonishing Hypothesis. He stated, point blank, that your joys, your sorrows, your memories, your ambitions, your sense of personal identity, all of it is nothing more than the behavior of a vast assembly of nerve cells and their associated molecules.
You are your brain, full stop.
Exactly. You are your brain.
And Crick genuinely thought people would find this liberating. He viewed it as a triumph of scientific clarity, but he drastically underestimated the emotional and psychological revulsion that pure materialism triggers in the average person.
Oh, completely. Let's talk directly to you, the student listening right now. If you hear Crick's hypothesis that you are, quote, nothing more than a pack of neurons, unquote, and your immediate reaction is existential dread or anger or just a deep sense of despair, you aren't alone. You are having a very normal human reaction.
Materialism feels like a demotion. For centuries, we viewed ourselves as the pinnacle of creation, imbued with a divine spark. To be told that we are essentially moist computers feels like it destroys everything that gives life meaning.
Right. People fear that if we are just machines, we aren't truly in charge.
If I'm just a biological machine, a cascade of chemical reactions operating in a closed physical universe, where is my free will? If I didn't author my thoughts, how can I be held morally responsible for my actions? It feels like a threat to moral responsibility and the meaning of life.
But it's not just philosophical stubbornness, is it? Dennett argues that our brains actively resist seeing themselves clearly. He calls this psychological force Cartesian gravity.
Yes, and the metaphor of gravity is quite deliberate. Physical gravity pulls mass toward the center of a planet. Cartesian gravity is the relentless psychological force that pulls our reasoning back into an egocentric, first-person point of view.
Like it just drags us back.
Whenever we try to objectively study the mind from the outside, Cartesian gravity violently yanks us back into the subjective feeling of being an immaterial soul.
Let me demonstrate exactly how strong that gravitational pull is with a real-world scenario for you, the student. I want you to pause for a second and answer a simple question. How many windows were in your childhood bedroom?
That's a great exercise.
Think about the room. Picture the door. Now count the windows. How did you do it? You almost certainly closed your eyes, generated a visual image of the room in your mind, and you, quote-unquote, looked around the space with an inner eye, counting the windows one by one.
The mechanism of what you just did is fascinating. Because intuitively, it feels undeniable that there is an inner theater inside your head. You feel like there is a screen, an image of a room is projected onto it, and a tiny version of you, a homunculus, is sitting in the audience looking at that projection.
It feels wildly obvious. I can literally see the curtains in my mind.
But neurobiologically, there is no image, there is no screen, there is no projector. If a surgeon opens your skull while you are thinking about your childhood bedroom, they won't see a tiny glowing hologram of a window hovering over your cortex.
It is pitch black.
Your brain is simply retrieving stored spatial and relational data across neural networks. But Cartesian gravity makes you insist that the image is real. The brain is presenting data to you in a format that feels like seeing because the visual cortex is being stimulated, but it is a benign illusion. You are experiencing the data, not looking at a picture.
It is incredibly difficult to shake that feeling.
Yeah.
Dennett uses the classic duck-rabbit optical illusion to explain why it's so hard to reconcile these two views.
The duck rabbit is a famous 19th century ambiguous line drawing. If you look at it one way, the protrusions are the ears of a rabbit facing right.
Right.
If you look at it another way, those same protrusions are the beak of a duck facing left. The defining feature of the illusion is that you can see the duck and you can see the rabbit, but your brain physically cannot process both interpretations simultaneously. You have to flip back and forth.
And when we try to understand our own subjective experience of reality, we are trapped in the exact same perceptual flipping. You have the third-person perspective, the objective scientific view of neurons, neurotransmitters, and action potentials. That is the duck.
And then you have the first-person perspective, the subjective feeling of love, the vivid memory of your bedroom, the raw experience of consciousness. That is the rabbit.
You start reading a neuroscience textbook, tracking how a photon hits the retina and travels down the optic nerve. You are firmly in the third-person duck perspective. But the moment you ask, yes, but how do those electrical signals make me feel the vibrant red color of an apple? Boom! Cartesian gravity has just snapped you back to the rabbit.
You are back to looking for the immaterial soul.
So how do we study this without falling into the trap? If Cartesian gravity is this powerful, invisible force constantly pulling us off course, how does a skeptical student approach this material without looking for the inner theater?
The most practical, simple advice is to deliberately bracket your gut intuitions. Treat your incredibly strong feelings of having an immaterial mind not as infallible truths, but as an object of study.
So just because it feels intuitively obvious that the sun revolves around the Earth doesn't make it true.
Exactly. Astronomy required us to bracket that intuition. Similarly, you have to look at your own consciousness and remain objective by asking, why would natural selection design a brain that goes out of its way to trick itself into feeling like it has an immaterial soul? Treat consciousness as an evolved phenomenon, not magical stuff.
Put the intuition in a box. You don't have to pretend you don't feel it, but you can't let it be the premise of your scientific inquiry.
Precisely. You study the illusion itself, and once we manage to temporarily break the spell of Cartesian gravity, we can make our second conceptual leap.
From evolution to intelligent design.
Yes. We can look at how the physical, biological brain actually managed to acquire the incredible, flexible intelligence that allows us to even have this conversation, and how our human toolkit differs from animal intelligence.
Here's where it gets really interesting, because we have to figure out how we got from the blind, uncomprehending competence of early life to deliberate human intelligent design. And the best way to understand human uniqueness is to look at how we differ from the rest of the animal kingdom.
When we look at animals, people tend to fall into two polarizing camps regarding animal intelligence. Dennett calls them the romantic view and the killjoy view.
The romantics look at a pod of orcas coordinating a hunt, or a chimpanzee comforting a grieving troop member, and they see humans in fur coats. They project deep philosophical reasoning and rich, poetic inner lives onto the animals.
Whereas the killjoys are the strict behaviorists. They look at the exact same animals and see nothing but biological clockwork. Meat robots driven entirely by stimulus and response, completely devoid of any inner life or genuine cognition.
But Dennett argues that biomass is mostly uncomprehending bacteria, plants, and insects. And even complex animals exhibit this competence without comprehension. Let's look at the bowerbird.
Oh, the bowerbird is a perfect example of this.
The male bowerbird builds these incredibly elaborate structures on the forest floor to attract a mate. He will arrange blueberries, blue beetle wings, and blue pieces of plastic in perfect symmetrical gradients. It looks like the bird has a master's degree in architecture and a deep aesthetic understanding of color theory.
It looks like pure intelligent design. The romantic assumes the bird is an artist contemplating beauty, but the reality is that the bird has no idea why the blue berries look best next to the blue plastic.
It doesn't understand structural engineering.
No, it is running a highly evolved, genetically hardwired algorithm. The male bowerbirds, who possessed the genetic mutation to arrange blue things symmetrically, successfully mated. The ones who didn't died out. The bird is exhibiting staggering competence, but it still lacks comprehension.
So how do we climb out of that purely biological programming? How do we map the evolutionary ladder from the hardwired bird to a human being who can understand physics?
Dennett provides a fantastic framework for this, categorizing cognitive evolution into 4 creatures. This framework beautifully illustrates how intelligence layers upon itself.
Walk us through it.
The foundation, the most basic level, is the Darwinian creature.
This is your standard hardwired organism. Trial and error over generations.
Correct. A Darwinian creature is entirely pre-programmed by its genetics. Its behavior is rigid. Crucially, a Darwinian creature cannot learn during its own lifetime. The only way learning happens is across generations, through the brutal process of natural selection. The organism generates random genetic variations, and the environment acts as the filter.
If a Darwinian creature is born with an instinct to walk toward the smell of a predator, it just walks toward the predator and gets eaten. The bad idea dies with the creature.
It is effective over millions of years, but locally it is a very expensive, deadly way to learn, which brings us to the first major biological upgrade, the Skinnerian creature, named after the famous behaviorist B.F. Skinner.
Okay, so what can they do?
These creatures have a nervous system that allows for plasticity during their own lifetime. They learn via operant conditioning.
This is the lab rat pressing the lever for a food pellet, or a dog learning to sit for a treat.
The mechanism here is pain and pleasure. The creature tries various behaviors randomly. If a behavior triggers a pain receptor, the neural pathway associated with that behavior weakens. If the behavior triggers a dopamine release from a food reward, the pathway strengthens.
So he doesn't have to die to learn.
Right, it just has to experience a bit of physical discomfort. But it is still blindly stumbling through its physical environment, letting the world dictate what works and what doesn't.
But stumbling blindly through a world filled with cliffs, predators, and poisons is still incredibly dangerous. I mean, even if you can learn from pain, touching a venomous snake to see what happens is a really bad strategy.
Very bad.
So evolution provided a safer way to test the waters with the third step, the Popperian creature, named after the philosopher of science Karl Popper.
Popper gave us one of the greatest summaries of this cognitive leap when he said that this adaptation allows our hypotheses to die in our stead.
What a profound idea. How does a Popperian creature let its hypothesis die?
By developing an internal, simulated model of the external world. A Popperian creature can test an action virtually before executing it physically. It can look before it leaks.
Like simulating the future.
Imagine a gazelle being chased by a lion. The gazelle encounters a split in the path. A Skinnerian creature might randomly run left, fall into a ravine, and die. But a Popperian gazelle takes a fraction of a second to simulate the outcomes internally. If I run left, the terrain is loose, I might slip. If I run right, the brush is thick, I can hide.
It tests the hypothesis in its mental model.
Yes. And the run left hypothesis results in death within the simulation, so the gazelle discards it and runs right in reality. The bad idea died, so the gazelle didn't have to.
Most higher mammals and birds operate at this Popperian level. It is a massive survival advantage. But it is still restricted by the limits of the individual animal's brain and its immediate experiences. The final step, the leap that makes us distinctly human, is the Gregorian creature.
Named after the psychologist Richard Gregory. A Gregorian creature does not just rely on its own internal biological model. It reaches out into the environment and imports thinking tools to fundamentally upgrade its own cognitive architecture. Humans are Gregorian creatures. We use thinking tools to organize our minds.
Let's list some of these basic thinking tools that enabled our evolution. Spoken words are the foundational one.
Yes, language is key.
Then reading, writing, arithmetic. Then physical tools that expand our senses, compasses, telescopes, microscopes, and eventually computers. These tools don't just help us do things easier, they literally change what our brains are capable of conceptualizing. They enabled humans to even understand their own evolutionary origin.
Think about a student listening to this deep dive, trying to learn these complex philosophical concepts. Applying this to how you, the listener, can improve your learning is huge.
How does a student do that?
You don't do it by wandering around the woods waiting for natural selection to mutate your brain. You do it by acquiring words and concepts. Dennett compares acquiring a new concept to downloading a Java applet into your brain.
I love the software analogy. Imagine the concept of a warning. If you are a purely Skinnerian toddler, the only way your brain learns that a hot stove is dangerous is by physically touching the metal, burning your skin, crying, and letting the pain receptors rewire your behavior. It's a slow, painful process.
But because that toddler is a Gregorian creature equipped with the cognitive plug-in of language, a parent can simply say, "It's hot, it will burn you."
You just download the warning.
By downloading that verbal warning, the child's brain incorporates the danger into its internal model without ever having to experience touching a hot stove. You skip thousands of trial and error cycles. You get the competence of knowing the stove is dangerous without having to suffer the consequences of comprehension. We inherit the hard-won wisdom of our ancestors.
But this introduces a massive biological puzzle. How does the physical brain handle these tools? Because our brains evolved over millions of years to forage for berries, track animal footprints, and avoid predators. They're animal brains. So how is it biologically possible that this same squishy organ is suddenly running the software of calculus, quantum physics, and poetry? It wasn't designed for that.
This is one of the most brilliant parts of Dennett's synthesis. He asks us to look closely at the architecture of the brain, and he introduces the concept of feral neurons.
Feral neurons, like wild animals that have been partially domesticated.
The analogy is very intentional. We often compare the brain to a computer, but the physical architecture of a silicon computer is a strict top-down dictatorship. It has a central processing unit, a master clock, and every single bit of memory and processing power is rigidly assigned, like a Politburo design.
Nothing happens without the central command's authorization.
But the human brain is massively parallel. There is no boss neuron sitting in the prefrontal cortex giving orders.
How does it work?
Dennett reminds us of the evolutionary history of the neuron. Billions of years ago, the ancestors of our neurons were free-living, independent, single-celled organisms fighting for survival in the ocean. When they merged to form multicellular organisms, they didn't completely lose that selfish survival instinct.
They're still feral.
Neurons operate more like individual agents in a free market than obedient soldiers in an army. They are competing and forming coalitions to take on new jobs. They constantly compete for metabolic resources, glucose, oxygen, blood flow, and they secure those resources by finding work to do.
So the brain is an incredibly competitive, chaotic marketplace. And this explains how brains acquire new skills. We know from neuroscience that neurons that fire together wire together.
Hebbian learning, yes.
When you try to learn a completely new cultural tool like reading music or playing the violin, there is no genetic blueprint for that in your DNA. Violins were invented far too recently.
The cultural tool, the meme of reading music, essentially invades the brain. Because there is no assigned real estate for it, the process of practicing forces neighboring feral neurons to recruit each other. They gang up, wire together, and take on this new processing job to handle the load and secure energy.
The culture is literally co-opting and domesticating these competitive neural agents.
Yes, rewiring the physical architecture of the brain to run new software. Which brings us right to the precipice of our third and final conceptual leap.
Turning our minds inside out. If our brains are just free markets of feral neurons processing thinking tools, where does the I come from? How do we get the subjective experience of being a conscious self?
We have arrived at the core thesis, the most challenging and controversial idea in Dennett's entire philosophy. Consciousness is an evolved user illusion.
Illusion is a very dangerous word to use here. When people hear illusion, they immediately think of a David Copperfield magic trick, a hallucination, something fake that doesn't exist at all. We have to be incredibly precise about what a user illusion is. Let's compare this to a smartphone or computer desktop interface.
The graphical user interface is the perfect way to understand this.
Imagine you are looking at your computer screen. You see a little yellow icon of a manila folder. You use your mouse to click on the folder, drag it across the screen, and drop it into a little icon of a metal trash can. It feels incredibly intuitive. It feels like you are physically moving a container into a bin.
But if we unscrew the back of your laptop and look at the motherboard with a microscope, are we going to find a tiny paper folder?
Are we going to find a tiny metal trash can full of deleted emails?
Obviously not.
No. The physical reality of the computer is a mind-numbingly complex chaos of microscopic transistors. There are billions of electronic gates flipping between 1 and 0, routing electrical currents at the speed of light. That is the machine code. If you, the user, had to interact with the computer at the level of machine code, typing out strings of binary just to move a file, you couldn't do it.
The complexity is too vast.
So what did the software engineers do? They created profound simplification. They built a graphical user interface. The folder, the trash can, the cursor, they are a user illusion. They are metaphors. They aren't physically real, but they are an illusion created so the user doesn't have to understand the mind-numbingly complex machine code underneath.
Dennett argues that our consciousness works exactly the same way to hide the complex neuronal machinery from us. The brain is the hypercomplex machine. It is running billions of feral neurons in parallel, processing millions of bits of sensory data per second, regulating heart rate, balancing hormones.
If you had to manage all that, you'd be paralyzed.
So evolutionary processes engineered an interface. Consciousness is the brain's simplified, metaphorical, heavily edited digest of its own operations. It presents us with a dashboard of thoughts, emotions, and urges. We don't experience the complex cascade of cortisol. Our dashboard just flashes a big red warning light that feels like anxiety.
Anxiety is the manila folder. And the expert consensus in modern cognitive science relates this directly to predictive coding. Can you relate the user illusion concept to modern cognitive science experiments?
Yes, specifically Bayesian hierarchical predictive coding. For a long time, the standard model of perception was bottom-up. You open your eyes, photons hit your retina, the data travels up the optic nerve, and the brain pieces the data together.
Like a camera taking a photo.
Predictive coding suggests the exact opposite. It suggests the brain is fundamentally a prediction engine. It operates top-down. The brain doesn't just passively receive information, it constantly guesses what will happen next based on past experiences. It generates a full-fidelity simulation of reality before the sensory data even arrives.
So my brain is just actively hallucinating reality.
Yes. And the sensory data streaming in from your eyes, ears, and skin is only used to correct the errors in that prediction. If the sensory data perfectly matches the brain's hallucination, the brain largely ignores the input. It only pays attention to prediction errors, the surprises.
Let me give a very relatable example of this. Have you ever been walking down a flight of stairs in the dark? You think there's one more step at the bottom, so you put your foot down expecting solid ground. But you're already at the bottom. Your foot hits the floor a fraction of a second earlier than your brain predicted.
We've all felt that.
What happens? You experience a massive, jarring physical shock. Your heart skips a beat. You feel a jolt of adrenaline. Why? Because your brain's top-down prediction severely mismatched the bottom-up sensory data. That jarring feeling is a prediction error, flooding your consciousness, forcing you to update your internal model.
It is the exact same mechanism that modern AI uses to learn. When AI learns to identify handwritten digits, it generates a guess, compares it against the actual image, calculates the error, and adjusts its internal weights. Our brains generate our smooth, continuous experience of reality by continuously generating guesses and suppressing the errors.
And realizing that our reality is just an internal hallucination forces us to confront David Hume's strange inversion.
Yes, the 18th century Scottish philosopher. Hume realized that we think the world has intrinsic properties, but it doesn't.
Let me push back here, because this is where Cartesian gravity pulls the hardest. Are you telling me that a spoonful of sugar isn't actually sweet? Are you telling me that the red stripe on a flag isn't actually red? Because sugar is sweet. A red stripe is red. I have a vivid experience of tasting sweetness and seeing redness.
Let's follow the physics of the sugar. Is there a physical property called sweetness residing inside the molecular bonds of a glucose molecule?
Oh, no.
If you look at glucose under an electron microscope, do you see little glowing particles of sweet?
No, it's just carbon, hydrogen, and oxygen arranged in a specific geometry.
Exactly. Sweetness is not in the glucose molecule. It is projection of our brain's reaction. When that specific molecular geometry binds to your taste receptors, it initiates electrical action potentials that travel to your brain. Your brain processes that chemical data and releases a reward signal.
And the illusion hides that process.
Right. Your brain doesn't want you to know about the electrical signals. That is machine code. So it projects the reaction outward. It tricks you into believing that there is an indescribable quale, a raw feeling out there in the world.
And there's no red stripe in the brain either. The flag reflects electromagnetic radiation, but a wavelength of light does not possess the feeling of redness. Our brain processes the wavelength data and projects the subjective experience of color outward.
The interface simplifies reality so we can navigate it.
Okay, so we have reached the climax of Dennett's philosophy, and we need to address common criticisms. The biggest criticism from skeptics, from a student who has followed us this far, might be panic. Are you saying my consciousness and my free will don't exist? Am I just an automaton?
If we connect this to the bigger picture, Dennett is absolutely not saying they do not exist. He clarifies that they do exist, but not as magic.
They aren't miracles defying physics.
They exist the same way dollars, promises, or penalty boxes in sports exist. Think about a $100 bill. Does it possess intrinsic value? From the perspective of pure physics, the value is an illusion. It's just cotton and ink.
But try walking into a grocery store and telling the cashier that the $100 bill doesn't exist.
Of course it exists. It is a real, vital part of the human manifest image, our world of practical interaction. Or think about the penalty box in ice hockey. It wasn't forged in the Big Bang. It was invented by human minds. But it is an absolutely real, functional part of the game.
Consciousness and free will exist in the exact same way. We don't need to abolish the concept of free will. We just need to realize it is an evolved, practical system of moral responsibility, not a supernatural power isolated from physics.
Discovering how a clock works doesn't mean time ceases to exist. It just means you understand the clock.
Let's briefly recap this massive journey. We covered 3 conceptual leaps. First, breaking the spell of top-down design and seeing how blind, uncomprehending processes can bubble up to create brilliant biological design.
Second, seeing how thinking tools and cultural plugins invade our brains, rewiring our feral neural networks to upgrade our animal brains.
And third, realizing that consciousness is a user illusion that allows us to interface with our own terrifying complexity.
And as we wrap up, I want to address you, the listener, directly one last time with a final provocative thought. Now that you know your consciousness is a user illusion, think about the very words you're using to formulate your thoughts right now.
Your internal monologue.
Are you speaking those words or those culturally evolved memes, those feral neural circuits, using you to replicate themselves?
Who is truly in the driver's seat?
Mm-hmm.
We all want a clean X-ray showing a unified soul steering the ship. But you are a chaotic, brilliant, evolving ecosystem of uncomprehending parts that somehow managed to invent the user illusion of you. Let that sink in.